Section 4.3, we talked about properties of chords. We're going to talk about properties of tangents here. And let's take a look at what a tangent is once again. So if you take a circle, a tangent is a line or portion of a line that will intersect that circle at one and only one location. Okay, so the line itself is called the tangent. The point that's shared between the line and the circle is called the point of tangency. And there's several relationships involving tangents that I want to review with you today. Okay, the first one is in a circle, the radius and the tangent will always intersect at a right angle. Okay, so a radius and tangent will always intersect at a right angle. So if I were to draw in this tangent, or I'm sorry, this radius from my circle, it's guaranteed to give me a right angle. Okay, you can kind of take this same statement, turn it around slightly, and get a similar statement, which is a perpendicular through the point of tangency will pass through the center of a circle. Okay, so if you have a tangent line and you want to find where the center is, you can do similar to what we did with the chords. A perpendicular through that point of tangency is going to pass through the center of a circle. And now these two relationships allow you to do a couple other constructions that you're going to be asked to do in this section. Okay. So one of those constructions will be the following. All right. So if we go back to this list of special properties that we need to be aware of, okay, the second property that I want to discuss is that if you have tangent segments that originate from the same exterior point, they're always going to be equal or congruent. What that means is if I took a second tangent and extended it from this point and even a third one, and extended these, what you will see is if we were to label these points, let's call it A, B, C, D, E, and F. Okay, the relationship that exists when you take these tangent segments that originate from the same exterior point is that any tangent originating from point A is going to have the same length. So these two segments right here from point A to the tangent, points of tangency, are always equal. The same is true here. From this point C, this tangent segment is the same length as any other tangent segment that's formed from that same point. And then finally, and I'll just leave it in blue here, EF and ED are going to be equal in length as well. So if you look at the sample problem on page 74, and if you're told that AB is 10, AC is 13, CE is 9, and then let's say GF was 4. Okay, so when you're looking at this, you know that the other tangent segment from A also going to be 10. The other tangent segment from B, or I'm sorry, from G will also be 4. If the whole length AC was 13 and AB was 10 of it, what's left for BC? So that this portion has to be 3, which means this other portion is 3. The whole thing was 9 and CD was 3. What's left for DE? The rest of this has to be 6, which means this length also 6. And so now you can find the perimeter by just adding those together. Easiest thing to do is just add things that combine easily. 6 and 4 is 10. 6 and 4 is another 10, so that's 20, 30, 40. 3 and 3 is 6. So you get 46 for your total.